Hello. In this video, we're going to do an introduction to DCF analysis, or discounted cash flow analysis. Now, what discounted cash flow analysis is for valuing securities, right? We can think about this as stocks, private companies, a specialized security you might be interested in as well. What's important is that we're going to take cash flows, projected cash flows from that security, and then discount them back to present value based on the riskiness of those cash flows. So how do we estimate those cash flows? We estimate those cash flows typically with projected financial statements. Right? You've been spending a lot of time working on projecting income statements, balance sheets, and statements of cash flows. We use those financial statements to project our cash flows out, and those cash flows are what we're going to use to discount back to present value to get the value of these securities. All right? And we're going to use those projected financial statements and cash flows to get what are called our explicit period cash flows, or our explicit period forecast. We're also going to have a terminal period forecast. And let me show you what I mean in an example. So in this example, what we have, you can see that we have an explicit period ranging from 0 to 5 years, and then a terminal period starting in year 6. So in the explicit period, this is what we would be getting from our financial statements, right? You would project out your financial statements. Through the statement of cash flows, we can get out our projected cash balances. In this example, we start with an investment amount of $1,000, so that's what we have in time 0 and a $1,000 outflow. We then get a $100 inflow in year 1, and then that grows at this 5-year growth rate over this explicit period of these first 5 years. All right, so you can imagine that's where you're actually going to explicitly forecast all your financial statements, and this is what you get back out. Alternatively, once we get to the terminal period, that's when we're going to stop forecasting our model and assume that the company is in a steady state position where we can assume constant growth and a constant discount rate forever at that point. So let's see a little bit more detail of that before we get back to the model. So as I said before, the explicit period is typically the period over which you can forecast financial statements. This could be anywhere from 2 to 10 years or even longer depending on the business that you're in. Typically, we see these as about 5 years as kind of the average. But again, depending on the industry, the business, you might see shorter or you might see longer. And the important part is that this is where we feel like we can confidently forecast the business's cash flows over this period of time. And not only that, but at the end of this explicit period, we think we can get to a steady state or an equilibrium state where the company is going to grow at roughly that same rate forever. And importantly, we have to get to a point where they're going to grow at a relatively small rate forever, right? Because if we make this assumption that they're going to continue growing at X% forever, well, if that X% is 20% per year, well, that just can't be the case, right? The economy doesn't grow at 20%. It grows at more like 2 to 3%. So if one company is growing at 20% before too long, and actually not too long at that growth rate, they would take over the entire economy. So we have to be careful when we get to our terminal period. We're not only getting to a point where we feel like the company can reach stable growth at that point, but also that that stable growth is low enough to really be a reasonable number. So as long as you keep that kind of terminal growth rate under 5% or so, you're probably going to be pretty safe. 2 or 3% at the growth rate of the economy is also a pretty good bet. All right, so let's return to our model and see what we're doing there. So in this model, what we can see is that in our terminal period, that growth rate is based on the period 5 cash flow times 1 plus our terminal growth rate of 5% in this example. So that's going to be what we use to represent all future cash flows going forward, right? So we need a way to think about how do we value those cash flows, because it's pretty straightforward to value this set of cash flows, right? We have a time 0, 1 through 5 cash flows. We have a first 5-year discount rate, and so we can easily discount those all back one at a time. You can see that doing this, we have a pretty simple way of making it work. Right? We take our cash flow divided by 1 plus R, our discount rate, raised to the number of years. So that is 100 divided by 1.1 to the 1. Here we have 105 divided by 1.1 squared, and so on. Now when we get to the terminal value, we have to use a perpetuity in that calculation. So when we start to talk about valuing the terminal value, we have a couple pieces of terminology we want to add in. The first is this idea of a stepping stone year. All right, the stepping stone year is that first year after your explicit forecast period, which in the model I showed is the terminal period. And that's that first year of kind of the rest of the company's life. All right, at that point, the company is growing at that steady state forever. So we're going to call that the stepping stone year. We're then going to think about the terminal value as the value of the company using a perpetuity based on that cash flow in the stepping stone year. We have to discount that back at a certain rate, though, and that rate we're going to call the capitalization rate, or the cap rate. All right, that's kind of the short form. And all that is that terminal discount rate, R, minus the terminal growth rate, G. So R minus G, we call that the cap rate. Now, when we do that calculation, you can see it on the slide here, the actual calculation is that cash flow in the stepping stone year divided by R minus G. That calculation gives us the present value as of the last explicit year in our forecast. So to get that back to time zero value, to today's value, we have to discount it back. And that's what we're going to call the reversion value. And the reason we have a special name for it is it's very common to calculate the terminal value and simply add that into our NPV. But that doesn't account for the fact that that terminal value is at the end of the explicit period. So we have a special term, the reversion value, to remind us that we need to take that terminal value and discount that back to time zero. All right, let's see what that looks like in our example model. Now you can see I've added in the terminal value here, and the way it's calculated is by taking that last period's cash flow divided by R minus G. Alternatively, we could separate out that R minus G and instead sub in the cap rate. Right? They're really the same thing. The cap rate is R minus G of that terminal growth period. Now the reversion value, right, this is where this other term comes in, is where we discount the terminal value back to time zero. And we do that by discounting at the 5-year discount rate, so that 10%, back for 5 years, the last of the explicit growth period. And finally, the last term you'll remember was our stepping stone year. All right, that's going to be an alternative term for when we start that terminal period. Now finally, once we've taken in the value of all our cash flows and the reversion value, that gives us the total present value of the company. Or in this case, it's actually the net present value because we've included the $1,000 investment at time zero. Now I want to impress upon you that the terminal value and the assumptions behind it are very important in driving the valuation or that net present value that you get out of your model. And the reason is that when you make assumptions forever, those assumptions carry a lot of weight. So you need to be careful that you think about, are those really reasonable cash flows going into the terminal period? Are we also growing at a reasonable terminal growth rate? And finally, is that discount rate also what we would see as reasonable? It's not too low that we're going to get overinflated values in our terminal value. So to demonstrate this, I want to go back to our model one more time, and we're going to see how the valuation changes as we change some of the assumptions in the model. All right, so we're back in our model, and now I want to see how changes in the 5-year discount rate affect value versus changes in the terminal discount rate. So let's say we underestimated how risky this company is, and we think instead that it should be 15% as a discount rate. So let's start out by just taking our 5-year discount rate and making it 15%. What we see is that the present value goes from $1,000 down to $635. All right, let's remember that. And now let's change the terminal discount rate from 10% to 15%. Now our total present value has gone down to $208. Right, there's a much bigger effect from that terminal discount rate than the explicit 5-year period discount rate. So let's put that back, and we can see the same thing happen if we actually decrease the discount rate. Decreasing it to 8% leads to a small increase in value for the company. Decreasing the terminal discount rate nearly doubles the value of the company. Right? We made a 2% change in our discount rate from 10 down to 8%, and the value of the company went from $1,000 to over $2,000. So big changes from that terminal discount rate. Same thing from the terminal growth rate. Let's say that 5-year growth rate goes from 5 to 8%. All right, a modest 3% growth rate. We get a higher value, which makes sense. It goes up from 1,000 up to about 1,200. Now if we change that back to 5%, and now let's change our terminal growth rate to 8%. Now we have a huge increase in our value. right? We more than tripled the value of the company by having that same 3% increase in growth rates. It just applied to the terminal period where the valuation is much more sensitive to. So the takeaway here is that your terminal period is going to be much more important in your valuation. Oftentimes, terminal values make up as much as 80% of valuations of companies, even 100% sometimes if near-term cash flows are all zero or negative. And so really making our best effort to get that terminal growth rate assumptions correct or at least reasonable is going to be really important for us. All right, so one really important thing to remember in all of this is that we're doing a big exercise in estimation, right? What I'm teaching you here is both science and art, right? The science part is much more how do we do this valuation? How do we get the numbers into the spreadsheet and do it properly, right? That's the science side. The art side is recognizing that all of this is estimates, right? We're estimating cash flows. We're estimating discount rates. And we're doing our best job to do it, but we do always have to remember that we're guessing here, right? Our valuations are never going to be right? We're not going to get it right on. We hope to get close and to be closer more often than not, but we just got to recognize that this is all estimation. Now, how do we estimate the numerator? Well, in that case, we're going to use a business plan, right? We're going to take our business plan, put it into financial statements, and then analyze those financial statements to get our valuation cash flows out. That's what we're going to use to discount. How do we estimate the denominator or the discount rate? Well, there we're going to use markets, right? We're going to look at other comparable companies. We're going to try to estimate their riskiness, compare our company to them, and try to get market-based measures whenever possible to estimate that discount rate. You've probably heard of weighted average costs of capital or using the capital asset pricing model, CAPM, to estimate firms' betas. Those are different ways that we can get it what that discount rate is that's appropriate to use in our DCF valuation.